It's all Greek to me. So we're going to talk about. I want to talk about a list. The most important thing about a list is the lambda at the front. So, does this actually work, or is that just a rumour? A vicious rumour put about by dogs. Ah, there you go. There it is. So I'm going to translate it. So list. When you normally hear list, you think, oh, okay, standard list. You sit there and go, okay, standard list, I can have a string of, standard list of string words, assert that it's empty, I'm going to push a couple of things in there, it should be to, the front should be world, pop front, okay, we're all good. Now, I want to reduce the level of excitement here to forward lists, okay, which are sizeless, so to speak, I have no idea how big they are, but I want to reduce this down. Because I'm going to take this one step further. I want to go back to the 60s. I did that earlier today. It's a great decade. This was a lovely book I've got. You can find the PDF online. It's a lot cheaper, but it's nice to have a physical copy. Lisp 1.5 Programmer's Manual. Lisp was a really interesting language. Basically gave us the excuse to use parentheses beyond reasonable measure. And it had a particular model of single-linked lists that was particularly immutable. So I want to see if I can recreate that. And there's also an idea here in Lisp that is based on Lambda calculus, which we'll get to. So I'm going to use a different list. I guess I put non-standard, but there you go. List of words. Now, slight difference here. Same deal, empty, front, standard, null opt, is slightly different. So what I'm doing here is I'm basically saying you can always ask for the head, you can always ask for the front, it's just not going to be there, it's optional. But notice also, this is no longer imperative, it's a transformation. You no longer change the list in place, you request, please give me the list that you would be had you pushed front. Size of 2, well, yeah, that's fine, and then pop front, again, the same deal with pop front, you get the resulting list, you get that. Okay, so, here in this paper from 2008, 2009, Lambda calculus was the first object-oriented language, so that basically means we've got to talk about Lambda calculus. 1932, although this is a 1936 paper by Alonzo Church, he's the guy you need to blame for first and second and pair, just if you're wondering. It goes back to the 1930s, okay? And he observed, he's in defining Lambda calculus, we select a particular list of symbols consisting of the symbols open close curly brace, open close parens, lambda, and open close square brackets, and a numerally influent set of symbols ABC. Apart from lambda, we've got all of those in C++. How awesome is that? So we've got a really strange way of spelling lambda. So what I'm going to do is I'm going to create a Lisp-style list in the spirit of the William Cook paper in Alonzo Church. So here we have list nil. Nil is the empty list. So what we're going to do now is we're going to have cons, we're going to construct a list that have head and tail. We've seen head and tail this evening. Now that's private. You're thinking, where's the data? Where is the data and where are the rest of my members? You're right. There's your data and the rest of your members. So we're going to have empty size front, pop front, and push front. They're all standard function. There is no other data here. Now in implementation, we're going to go ahead. An empty list is empty. Return true. Return 0 for the size. Return null opt. You always return null opt. For the front, pop front, it's always an empty list, and then push front, you actually create something new. What you do is you create this, although we can tidy it up to this. Now what you'll see here is this is everything. This is effectively a very bad, what's called church encoding of a list. I make no claims for its efficiency. Actually, no, I make plenty of claims about its efficiency. Don't do this at work, all right? Okay, what we've done is we've got an object that is kind of self-modifying, and what it does is it replaces its own methods, or rather, it defines a successor object. And it says, here is the object that will contain the state. When you call pop, it will pop to whatever the tail you gave us was. And when you call push, we will call ourselves recursively. This is the bit that gets really fun. You'll take your own. You'll take the front, and you will look to this. And you basically created this nested set of closures that will baffle your colleagues for hours, if not days. Okay, the opportunities here are mindless and endless. So with that, I will leave you with that one letter to understand how far you should not take your lambdas. Thank you.